Hi, my name is Ashley Sear. Would you believe it if I told you that 2.1 million people in the United States suffered the repercussions of amputation? New research is being conducted by scientists who have the potential to return the sense of touch and mobility to those who dream of their lives before surgery. Experiments conducted have allowed humans with impaired neuronal pathways the capability to send messages from the brain to the robotic arm and vice versa, essentially replicating the biological limb. The brain communicates with the rest of the body through electrical and chemical signals that travel through neurons. These signals are released as a result of external or internal stimuli. Now, there are specific cortexes in the brain that correlate to each sense. The area involved in movement is named the motor cortex, which is located in the frontal lobe of the brain. The motor cortex sends out impulses to trigger the body to respond to a factor that will evoke a specific functional reaction in an organ or in a tissue. These messages travel to other neurons through synapses, which are tiny spaces in between cells, as you can see in the picture, until they reach their target cell, which has the ability to induce a physical response. Now, the entire concept revolves around a tiny pill-sized device called a brain-machine interface, or BMI for short. The BMI is made up of an array of tiny electrodes and is implanted directly into the patient's motor cortex. The electrodes act as conductors between the non-metallic impulses sent from the brain and the computer systems the researchers use to read the recorded information. The electrode's purpose is to record the brain's activity while the body is in motion. They are placed close enough to the neurons that when the brain lights up, they instantaneously document the activity, such as where the neurons are fired from. A computer receives the messages from the electrodes and translates the pattern of brain activity in a form that scientists can read and interpret. Then the scientists identify the number of signals sent, where they originated from, and which cells have the correct receptor, and even more. The researchers use their knowledge of how the brain initiates movement to program thousands of lines of code into a tiny interface implanted into the robotic arm, which then will be able to replicate the same pattern of cranial activity. This means that when the human brain fires a neuron to create a cellular response, the BMI will recognize such signals and transfer them to the interface located in the robotic arm. This will allow the artificial arm to be able to replicate the exact same motion the brain was attempting to achieve, but was just unable to complete due to the severed connections of amputation. This innovation will give a monumental amount of people a second chance at life by being able to perform simple tasks they were no longer able to execute. I plan to personally impact this topic by pursuing a career in biomedical engineering. After enduring numerous injuries as a child, such as hip surgery or a variety of ankle injuries, I've become fascinated with the body's movement. Engineering is the perfect field that will allow me to change people's lives, innovate, and build on my interests daily. I plan to specialize in prosthetic devices and formulate new technology as well as improve past discoveries in order to allow people a full range of motion after a limb has been severed. My breakthroughs will give patients their freedom and independence back that was once taken involuntarily. Thank you all so much for your time and for considering me for your scholarship.